This is a production of Cornell University.
Which then also sort of moves us into wind. Okay, water and wind are basically both working in fluid dynamics. Okay, water has a lot more mass, it's going to be a lot more energy behind that same flow. Okay, but air basically acts as a fluid. Okay, so the problems are in fact similar. Now, if most of our water, if you think about the energy of the water, there's going to be more energy in a fast flowing stream than a slow flowing stream. Right? Steep slope versus flat slope. Okay? Well, the same thing occurs with wind. Okay? Low wind, my object, each one of these in this case is imagine this is a sand grain or something like that across a flat table. The amount of energy hitting that is the wind. If there's less energy than the resistance of that object to move, you're not going to have any movement. Okay? The minute that the force of the wind is equal to or greater than the force of the object, you're going to start seeing that movement of the object. Okay? It increases, you start seeing it actually being picked up for periods of time, and if it really hurricane force type of winds, this stuff is going to be carried up into the ground, up into the air and carried long, long distances. Okay? This is a great scenario or a good example of what's happening from Africa, the African dust basically fertilizing the Caribbean and the southeastern United States. Okay? The wind patterns are such the wind moves across the African plains, okay, picks up dust, takes it up into high elevation, carries it across the Atlantic, drops some of it in the Atlantic, but also drops it in the Caribbean islands as well as the southeastern part of the United States. Now, a lot of that has to do with the force of the air, but it also has a lot to do with the type of object. The African dust that's coming across is not sand. It's clay and silt-sized particles, very small. So the resistance that this material has is a lot smaller than if this was a sand grain. Now, as with wind, we have a very similar equation. This is a wind erosion index, very similar to the water erosion index. Okay? E is the potential average of loss through wind erosion. I is the soil erodibility itself, the nature of that soil, again, sand, silt, clay, gravel, whatever it happens to be. Local climatic conditions, in essence, very similar to just sort of the rainfall, except in this case we're looking at wind velocity and, and how much moisture is in the soil. Okay? Roughness of the soil, this has to do very similar with the slope. Okay? How much scope that wind has to reach across the soil to actually carry something. Okay? The wind length, the actual scope of the field, and vegetative cover. Very similar to water, wind control basically uses the same strategies. Okay? Anything that we can put in place that reduces the amount of wind moving across our fields and reduces the amount of energy in that wind. Does that make sense? Very similar to water. In water, we're trying to slow the force of that water down. We're trying to anchor the material that's in place. Well, with wind, we're doing the same thing. Okay? There's a number of strategies that we use. One of them, and the biggest one, which totally makes sense, is windbreaks. Okay? In essence, I create some sort of roughness on my field to prevent the wind from having a high energy and to prevent the wind from having a long scope that it can pick up the soil. Okay? Basically, there's a sort of a rule of thumb. The distance that's sheltered by the windbreak is basically 10 to 20 times the height of the windbreak. That's this. So if I have a 10-foot tree, it's going to probably cover 100 to 200 feet. Does that make sense? Okay. Now, the sheltering distance increases somewhat with a number of things, water being another one. Okay. Going back to here, climate conditions, it's not just about what's going on with the wind, it's also what's going on with the surface. You can certainly imagine if my system is wetter, what's going to happen to the erosive nature of the material that the wind is going over? Is it going to become more erosive or less erosive? The more water I have in the system, Certainly it's going to get heavier, but the more water I have in the system, the more it's going to act like a glue, which means it's going to be less erosive. Also, the more water I have in the system, the more likelihood, the more vegetation I have growing. The more vegetation I have growing, the more stabilization I have. And with the grassy waterway, vegetation is going to act to reduce the speed of the wind. When you guys were kids, think about this. I don't know if you guys ever did this. On windy days, when you stood up, you felt how all the wind was on you? Okay, did anybody ever just sort of lay down on the ground? Do you ever remember doing that? Okay, you stand up, windy day, you lay down, and all of a sudden the wind is gone. It's not like the wind has disappeared. It's just you're down below the free flow of the wind. As the wind gets closer and closer to that surface, what happens to it? It starts to encounter resistance. It encounters resistance, what's going to happen to it? This is an easy answer. Come on. What is going to happen to it? It's going to slow down, right? If it slows down, it has less energy. In essence, the concept of this. Feel good about this? Yeah? This is, I think this is from your book. I'm not sure. Has anybody seen this picture before? If you have, it's probably from your book. If not, I stole it from someplace. Okay? Okay, think about how you put these windbreaks in. I got 2 minutes, okay? Think about how you put these windbreaks in. Why do I want to have an understanding about the nature of the wind of the landscape? Okay? It's not just how much energy it is and how fast it is, in essence. I also want to have an understanding about what direction it's coming from. Okay? If I look at this landscape, I basically have an understanding about which direction the wind is going. Because the farmers are going to be putting these trees or these windbreaks basically against the wind. Okay? So the wind, if the wind is moving this way, these windbreaks aren't going to be doing a lot. In all likelihood, the wind is moving this way or this way. Right? Makes sense? So thinking about how you put these in place. I think what I'm going to do is stop the, no, we'll finish up. Okay, so cover itself. Okay, the cover, what's the cover going to do? It's basically going to be holding that soil in place, just as we talked about with the water. Okay, it's going to hold the soil in place, but it's also going to be increasing the surface roughness. That's that laying down on a windy day, and suddenly the wind goes away. Okay, the other thing is that surface roughness is also going to hold on to things like snow. Okay, if it holds on to snow, that snow is going to melt there, which means that soil is going to be moist there. Okay, more moisture, more resistance to the wind. Okay, and certainly from a farmer's perspective, more moisture, my plants can then harvest it later on. Cultivation, this is not necessarily planting, this is actually the plowing. Okay, cultivation increases surface roughness. If I create hummocks, series of cultivation ridges on my field, I'm basically creating, now granted these can be eroded away, but I'm creating basically wind shadows behind them. So these guys basically add, or in essence act as windbreaks. Now they're very low, but they act 10 to 20 times longer than their height. So if I have 3 inches, I'm getting 30 to 60 inches of coverage. Now that may not be all that important for a tree that's up here, but for a seedling that's coming out, that could be a very big deal. And certainly also think about the moisture sense. Do you guys remember me talking about that ice cream cone in the fan? Okay. What's going to happen to that plant if it's sticking up in the wind? It's going to what? Evapotranspiration is going to dramatically increase because that wind is going to be drying out that plant, just like it melted the ice cream cone with the fan. Okay? So if I have a seedling coming up here, I want it to be out of the wind because I want the reduction of this ridge to protect, reduction of the wind by this ridge to protect that seedling so it doesn't dry out. Okay? Lots of considerations here. It's not just about keeping the soil in place, it's also what you're doing in that place.
This has been a production of Cornell University, on the web at cornell.edu.